Okay, here's a quick video about solving systems of equations. I'm moving back to the beginning. Sorry. Here we go. We're at the beginning. So we did in class today. If you have two lines, you can graph them. Okay, we're trying to find the intersection point. So if I have y equals 3 over 2x, 3 halves x minus 1, I'm starting at negative 1. I'm going up 3, 1, 2, 3, and over 2. Maybe do that again. 1, 2, 3, and over 2. Grab a line. Lovely. My next equation, I have y equals negative x plus 4. So I start at positive 4. My slope is negative 1 over 1. So I'm going down 1 over 1, down 1 over 1, down 1 over 1. And hopefully you can see right away that these two lines seem to be intersecting at the point 2, 2. This is my intersection point. Remember, you want to state what that intersection point is. This is my x, remember, and this is my y. And what that is, so the solution is 2, 2. And that means that these values for x and y are parts of both equations. They're in both lines. If these equations were linked to some sort of word problem or something, then 2, 2 would have some more significance in terms of solving that specific word problem. But we don't want to always graph. It's not always the most efficient method. Excuse me. Sometimes we want to solve algebraically. That means using algebra. And what we say is we want to solve by setting equal. Because both equations are set up equal to y, since y is the same thing, then we can say each part here, each expression, can be equal to each other. So the way we set this up is we set the expressions equal to each other. We say 3 halves x minus 1 is equal to negative x plus 4. And then I have one variable, just x. I'm going to just solve for x. So those of us that like to put the line down where the equal sign is, we're going to solve for x. I'll probably add x on this side and add x here. 3 halves x plus 1x. So 3 halves is like 1.5 if you need to think about that in your head. 1.5 plus 1 more. Isn't that going to be 2.5x? Let's leave it like that for now for those of you who are more comfortable. And 4, I'm going to add 1 over here because I want to get my regular numbers with my regular numbers. So I have 2.5x is equal to 5. 4 plus 1 is 5. Well, I can see clearly right now when I divide by 2.5 that x is equal to 2. 5 divided by 2.5 is 2. So I got my x value of 2, which is great. I need to find a y value now. So what you do is take either, oops, it doesn't like when I do that, either one of these equations and rewrite it over here. I'll probably take the one without the fraction because I know that's going to be a little easier. So I'm going to have y equals negative x plus 4. Well, I just found out that my x is 2. So I can plug that in for that x here. So y is equal to, the negative is part of the equation. My x is 2. I put that in there. Sometimes I like to put it in parentheses. Plus 4. Well, that's just going to be negative 2 plus 4, which is 2. So I've shown using algebra by first setting up an equation where there's just x, solving for x, and plugging that in, and get an equation for just y, then my intersection point is 2, 2. And if you remember back from our previous one, it was 2, 2. So that's reassuring. Let's do, I think I have 2 more examples. Here they are, just to double check. So this is equal to y, this part's equal to y, so I can set them equal to each other. So I can say 2x plus 1 is equal to 4x subtract 3. Get the x's together. So I'm going to subtract 2x this way. The reason I'm bringing the 2x to the right is because if I brought the 4x to the left, I'd have a negative, and I just don't want to deal with the negative. So I can see that and strategize about that. That's going to be 2x. I have minus 3. I'm going to add 3 over here. 4 is equal to 2x. Divide by 2. X is equal to 2. Another x is equal to 2. I'm not done. You need an x and a y. So take, again, either one of the equations here. I'm going to take the top one this time because it doesn't matter. It should work the same for either one. I'm going to put 2 in for this x right here. So I have y equals, this 2 is the original part of that equation. My x is also 2. I filled that in. And then I'm just simplifying. 2 times 2 is 4, plus 1, y is equal to 5. So I have 2, 5 as my x and y coordinate point. Now, we didn't check the last one because we had just graphed it, and so that was pretty much a check. But if we need to check our answer, take the other equation, the one you didn't use, y equals 4x minus 3, plug in 2 for the x, so 4 times 2 minus 3, 5 for the y, and make sure this works. 4 times 2 is 8 minus 3. Yeah, that's equal to 5, so this works out. That check's fine. One more example. Again, they're both equal to y. You can set them equal to each other. So we're going to say x minus 5 is equal to 3x plus 7. Draw the equal sign, or the line under the equal sign. I'm going to minus x from both sides to get the x's together. Combine like terms, right? Negative 5 is equal to 2x plus 7. I'm going to minus 7. Subtract 7. Negative 12 is equal to 2x. Divide by 2. X is equal to negative 6. All right, remember you're only halfway done. Take either one of these. I'm going to go with the top one. Y equals x subtract 5. Well, that means y equals negative 6 subtract 5, or y equals negative 11. So we think our coordinate point is negative 6, negative 11. I'm going to just do a quick check. Is 3x plus 7. So negative 11 is my y. 3 times negative 6 plus 7. Is that equal to negative 11? Well, 3 times negative 6 is negative 18. Plus 7, that works out to be negative 11, so that checks out just fine. I think this was a fast video, but it's all skills that we've done before, just applying them in a new way. Remember, if you're going to try and remember things, number 1, set them equal. This would be step 1. Get x. Number 2, plug in x and get y. Step 3 would be to check. See you in class.